So what we're going to do today is we're going to show you how to straighten a shaft, whether that be a pump shaft, a line shaft, a head shaft, and give you a rundown on the performance, why we do these things. So it's real important for the shaft to be straight, and here in our facility we like to straighten them within about 1/1000th of an inch of total indicated run out. What this does is by straightening it, you wind up not getting vibration in your pump in the field, which can lead to a failure. So what we have right now is an operator who's going to attempt to straighten a piece of bar stock. So you'll notice that he's got his tape measure out, and what he's doing is he's making sure that he has an even amount of space on the outside of the roller on both sides of the shafts. By doing this, he's given us some symmetry and a place to start. And what he's doing now is using a dial indicator, and he's going to place it on the top of the shaft, and you want to make sure that you have travel both directions on the indicator before starting the procedure. So as he's rolling the shaft, you can see that there's a good amount of run out in this shaft. And what he's doing is he's just located it to the high spot, which this shaft has a bend in it. As it rolls around, we want the high spot on the top of the shaft. What he's doing now is he's setting his torch. We're going to use heat to persuade that bend out of that shaft. So again, located on the top, he heats it and then quenches. The purpose of the heat and the quench is to try to get that run out to come past its top center. Now he's going to check it again. Apply heat. Every shaft will be different. The amount of heat that you apply depends on the metallurgy of the shaft. Often we find it's kind of a trial and error. After your first heating sequence, you can get a feel for how much heat that it takes to start to remove that bend. You can see he's removed quite a bit of it. This process sometimes requires multiple heating intervals. It's important, if you'll notice, he is not heating in the exact same spot every time. So if your high spot repeats back to the same point, you want to move your torch over a couple of inches and apply the heat again. Applying heat to the same spot more than a couple of times can cause a metallurgy hardening and can cause a weak point in the shaft. Okay, so now what he's doing is he's moving his indicator. So now he's moved to the end of the shaft. On this, he's finding the low side of the bend. Once that side's been straightened, we'll move to the other side of the shaft and repeat the same process. So once you've completed the middle and both sides of the shaft and you've got them straight, you'll move the dial indicator from the end to a couple of places in the middle and to the other end and verify the entire length of the shaft has been straightened. If not, repeat the steps from the start.